In this section, I'm going to go over how to multiply polynomial expressions and functions. Now remember in the last section, I went over the names for different kind of polynomials depending on how many terms they have. So a monomial, mono meaning one, has one term. And remember that it's the addition and subtraction that separates the terms. So with a monomial, there wouldn't be any addition or subtraction. In a binomial, bi meaning two, has two terms. So there would be one addition or subtraction to separate out the terms. And a trinomial would have three terms. Now I'm going to start with the simplest kind of polynomial, and that's one that has just one term, monomials. And we'll start by going over how to multiply monomials together. And then from there we can work up to the more complicated problems. Okay, so here's an example of two monomials that are being multiplied together. Notice this first expression has no addition or subtraction symbols, so that's one term. And the same with the second one. So we have a monomial being multiplied times another monomial. And in those kind of problems, really it's the commutative property of multiplication that allows you to do all the multiplications in a different order. So you can do the 6 times the negative 2 first and get negative 12. And then you can do the a to the 4th times the a to the 2nd and get a to the 6th. Notice you'd add your exponents there. And then you can do the b cubed times the b to the 6th. And again, you'd add the exponents, and 3 plus 6 would be 9. So it would be b to the 9th power. Okay, here's another example. Just remember, when there's no exponent actually written in, it's implied to be a 1. So this x here is really to the first power, and this y is really to the first power. And so we do the same thing as before. We do the 7 times the 2, and that's 14. And then we do x to the first times x cubed, which would be x to the 4th. 1 plus 3 is 4. And then we do the y squared times the y to the first, and that would give us y cubed. So you can see it's fairly simple to multiply two monomials together. And if you even had three monomials multiply together, you would do the same thing. You could just do the first two together and get that answer, and then multiply that by the third one. Okay, now we'll look at the next case, which is a little bit more complicated than the first case. So we're multiplying a monomial by a polynomial. So notice this first thing outside here is a monomial, that's just one term, and that's being multiplied by this thing inside parentheses, and that's the polynomial because there's three terms there. And so when we do this, we just want to make sure we use the distributive property. So the term that's outside gets multiplied onto each term inside the parentheses. And there's three different terms there. Again, they're separated by the addition and subtraction. And so when we do this, we'll just do them one at a time. So we'll have first negative 7w squared y times 6w squared. And the answer to that would be negative 42 w to the 4th, because you'd have to add those two powers together, 2 plus 2, times y. And then you go on to the second one, and so now we've got negative 7w squared y times a positive 2wy. So the answer would be negative, so it's going to be minus 14, and it's going to be w cubed, because you really have 2 plus 1 on the powers on the w. And then for the y's, you have 1 plus 1, so it's going to be y squared. And then you go to the last one, so it's negative 7w squared y times a negative 8y squared. Now a negative times a negative is a positive answer, so we'll write plus 7 times 8 is 56, and it's going to be w squared. And then we have y to the first times y squared, so that would be y cubed. And that would be your answer. You can't go any farther with this answer because if you look at these three terms in your answer, they're not like terms, and you can only combine like terms. In order to be like terms, they have to have the same exact variables and the same powers on those variables, and that's not true with any of those three terms in the answer. Okay, now we'll go to the next harder case, and this is where we're multiplying two polynomials together. So notice in this example, this first expression inside parentheses has two terms, a 5x and then a negative 6y, so that's a binomial. And then this second expression inside the second parentheses also has two terms, so that's another binomial. So neither one of those is a monomial, they're both polynomials being multiplied times each other. So we need to have a strategy for doing this. And the strategy that I like to show is, let's start with the first term in the first polynomial, that's the 5x. And we're going to distribute that onto each term in the second polynomial. Okay? So we'll multiply the 5x times the 3x and then the 5x times the negative 2y. And so let's actually do that. So 5x times 3x would be 15x squared. I'll write that down here. And then 5x times a negative 2y would be minus 10xy. Alright, now once we've done that, we're really through with 5x. You can kind of think of, crossing that off there. We're all done with the 5x. And so we move on to the next term, which is a negative 6y. Make sure to include a negative sign with it. And we're going to do the same thing there. We're going to distribute that onto each term inside that second set of parentheses. Put the arrows on top this time. So we'll have negative 6y times 3x. That's minus 18xy. And then we'll have a negative 6y times a negative 2y, which is a positive 12y squared. So at this point, we can look to see if we can combine any of the terms in our answer. Let's see if we have any like terms. This one's got x squared in it, and none of the other terms have x squared, so that can't be combined with anything. The second term has xy in it, and notice this term also has xy. So those two terms in the middle there are like terms, and they can be combined by adding the coefficients. So negative 10 plus negative 18 would be negative 28. So we'll combine those two together in our final answer. So we'd have 15x squared minus 28xy. Make sure to leave the xy the same. When you combine like terms, you don't change the variable part. You just add the coefficients. And then plus 12y squared. And that would be your final simplified answer. Now, a lot of people call this type of problem when you're multiplying two binomials together, which is really what we had, because each one had two terms in it. A lot of times they call it FOIL, and here's why. Because if you trace back through these different multiplications that we did, the first thing we did is we took the 5x and we distributed onto that 3x. So notice that's the first term times the other first term. So I'm going to call that F for the firsts. And then we took the 5x and we distributed over here to this negative 2y. And those are kind of like on the outside of the problem. That's the far left and this one's the far right. So that's on the outside. So those are sometimes called the outers. So I'll label that with an O for outers. And then we were finished with a 5x, so we moved on to the next term, negative 6y, and we distributed that onto the 3x. Now notice those are right in the middle, and they're often called the inners. So I'll label that with an I. And then we took the negative 6y times the negative 2y. That's the last term in the first one times the last term in the second one. So those are often called the lasts. And when we wrote the answers down, the 15x squared was really the firsts, and the negative 10xy was the outers, and the negative 18xy were the inners, and then the plus 12y squared were the lasts. And that spells the word FOIL. And sometimes FOIL is used to represent that kind of a problem where you're multiplying two binomials together. Now let's look at another example of a multiplication problem. This time we have a binomial, because this first one has 2 terms, being multiplied by a trinomial, because that second one has 3 terms. And we're going to do the same type of idea. We'll start with the first term in the first polynomial, the 3x, and we'll distribute that onto each term in the second one. And then when we're done with that, we'll move on to the second term in the first polynomial, and we'll distribute that onto each term in the second polynomial. So we actually have 6 different multiplications to do this time. We wouldn't call this FOIL exactly. You would need a 6-letter word for this one, but it's the same process as the FOIL process. We're multiplying each term in the first one by each term in the second one. So when we actually do this, we'll have 3x times 4x squared, that's 12x cubed. And then 3x times 5x is plus 15x squared. And then 3x times a negative 3 is minus 9x. And now we're really done with that first one, and we move on to the second one. And so we have 2 times 4x squared. Now that's 8x squared. Now one thing you can do is you can write the plus 8x squared underneath the other x squared term, because they're going to be like terms, and you will be able to combine those at the end. So sometimes it's nice to vertically line up the like terms. It's not necessary. You can write it all on one big long line if you like, but sometimes I like to do that. And then we'll have 2 times 5x is plus 10x. I'll write that underneath the other x term. And then 2 times negative 3 is minus 6. And then to combine the like terms, you can just vertically add these together. So we'd have 12x cubed. 15 plus 8 would be plus 23x squared. Again, don't change the x squared part, just add the coefficients when you combine like terms. And then negative 9x plus 10x would be plus 1x. You don't really need to write the 1, it's implied anyway, so it's simpler just to write plus x and then minus 6. And that would be your answer. Now in this next example, we're multiplying 3 different expressions together. We have a monomial 2x being multiplied by the polynomial x squared minus 7 times another polynomial x plus 3. And I think the best approach here would be to go ahead and multiply the 2 polynomials together first, and then multiply the 2x through that answer at the end. So I'm going to start by doing the 2 polynomials. So we'll take the x squared and distribute that, and that gives us x cubed plus 3x squared. And then we'll take the minus 7 and distribute that, and that gives us minus 7x minus 21. And this time none of those terms are like terms, so we can't combine anything there. So we just have to leave it like that. And then I'll bring the 2x down, and now we'll go ahead and distribute the 2x through each of those 4 terms. And that will give us 2x to the 4th plus 6x cubed minus 14x squared minus 42x. Now sometimes we have a binomial inside parentheses being squared, and it's important that we know how to set this up properly. In order to square a binomial, that means we have to take that binomial, in this case 7x plus 3, and multiply it by itself. So times another 7x plus 3. And now we have to multiply this out using the standard approach, using what I called before FOIL, where we do the firsts, and then the outers, and then the inners, and the lasts. So when we do that, first we have 7x times 7x, so that's 49x squared. And then 7x times 3 is plus 21x. And then on the inners, it's 3 times 7x, so that's plus another 21x. And then 3 times 3 is plus 9. And then when we combine the like terms, 21x plus another 21x will give us 42x. So we'd have 49x squared plus 42x plus 9. So it's really important that when you see something in parentheses raised to a power, that you take that expression in parentheses and multiply it times itself, and then do the multiplication out from there. Now let's look at kind of an application of this. We have the function given to us, f of x equals x squared minus 2x. And the problem says to find f of a plus h. Now, whenever we're trying to evaluate a function like this, we take whatever's inside the parentheses and we plug that in for x into the function. Now in this case we'll have to plug it in 2 different places because x occurs in 2 different places. And we need to use parentheses around the expression when we plug it in. So what we'll have here is that f of a plus h would equal a plus h in parentheses squared minus 2 times a plus h in parentheses. And then from here we have to do the multiplication. So now this is a situation just like we talked about where we have something in parentheses and it's squared. And the way we do that, remember, is to take whatever's in parentheses, a plus h, and then multiply it by itself again, so times another a plus h. And then we'll have to do the FOIL on that. So we'll do our firsts, our outers, our inners, and our lasts. And that would give us a squared plus ah plus ha, which is the same as ah, plus h squared. And then when we distribute this negative 2 through this second set, we'll have minus 2a and minus 2h. And then we want to look for any like terms. So we have a ah and another ah. And that looks to be about all the like terms we have. So we'll have a squared plus 2ah plus h squared minus 2a minus 2h. Now another special kind of multiplying is when you're multiplying what's called binomial conjugates. And that's any time you have something that's of the form a plus b times a minus b. And the a and the b could be anything. But in one case you're adding, and in the other case you're subtracting. So an example of this would be if you had something like 5x plus 9 times 5x minus 9. Now we'll do this just like any other multiplication problem. We'd have to do our firsts and our outers and our inners and our lasts. And when we do this, something a little different happens, as you'll see in a minute. So let's just go ahead and go through that process. So 5x times 5x is 25x squared. And then 5x times negative 9 is minus 45x. And then for the inners, we have 9 times 5x, so that's plus 45x. And then a positive 9 times a negative 9 is minus 81. And notice that the inners and the outers are opposites of each other, so they cancel out and add up to 0. So in our final answer, we just end up with 25x squared minus 81. Now that always happens when you multiply binomial conjugates together. The inners and the outers add up to 0, and therefore your answer, it just consists of the firsts and the lasts of the multiplication problem. Now in this next example we have 3 different polynomials to multiply together. We have x minus 1, then x plus 1, and then x squared plus 1. And you can't really multiply all three at the same time. You just have to do two at a time, and then take that answer and then multiply by the third. So we'll start with these first two. We'll go ahead and we'll multiply those together using our normal process of firsts and outers and inners and lasts. And then once we get that answer, we'll multiply that by this last one at the end. So when we do that first part, we'll have x squared plus x minus 1. And then we're still going to have to multiply that by this second one, so I'm going to write that in just so I don't forget about it. And then, just like we said, the inners and the outers of that first FOIL problem cancel out because those are conjugates again. So that first answer just comes out to be x squared minus 1. And then we're multiplying that by x squared plus 1. So now notice here that we have conjugates again, because this is of the form a minus b times a plus b. So a similar thing is going to happen here. When we do our FOIL, or our first, outers, inners, and lasts, the inners and outers are going to cancel out of that answer, as we'll see in just a minute. So we'll have x to the fourth plus x squared minus x squared minus 1. And just like we predicted, the positive x squared and the negative x squared add up to 0, and so they drop out, and we just have x to the fourth minus 1. The last thing I'd like to go over in this lesson is something called the product function. Now, product means multiply. So the product function is the function f times g of x. And as you can see, f times g of x just equals f of x times g of x. So we just multiply the two functions together. So let's assume we have two functions given to us. We have f of x equals 3x plus 2, and g of x equals 4x minus 1. And we want to find f times g of x and also f times g of negative 2. So let's first start by finding f times g of x. So f times g of x would equal f of x times g of x, which would equal 3x plus 2 times 4x minus 1. And we'd have to multiply that out using our multiplication process. And so when we do that, we'd have 12x squared minus 3x plus 8x minus 2. And then when we combine our like terms together, negative 3x plus 8x would be positive 5x. So we'd end up with 12x squared plus 5x minus 2. Now for the second part of the question, f times g of negative 2, we would just substitute the negative 2, the number in parentheses, in for where the x is in that answer. And so that would equal 12 times negative 2 squared plus 5 times negative 2 minus 2. So that would equal 12 times 4, because negative 2 squared equals 4. And then a positive 5 times a negative 2 would be minus 10, and then minus 2. And 12 times 4 would be 48. So that would equal 48 minus 10 minus 2. So that'd be 38 minus 2. So that would come out to be 36.